Hello, good morning everyone. Today we are going to see Operating System Unit 2, Session 8. In the previous topic, we have studied the concept process creation. Process creation are created using the system call, and in a Unix Linux system, the processes are created using the fork system call. And we also seen how parent and child processes are created. And in today's session, we'll study about process termination and basic of CPU scheduling. Process termination. Process executes last statement and then asks operating system to delete it using the exit system call. So whenever the process is finished its execution, it will ask the operating system to delete that particular process using the exit system call. So whenever the operating system invokes exit system call, that particular process will get deleted. Return status data from child to parent through wait system call. So whenever the child processes finishes its execution, it must return to the parent, and that is done with the wait system call. So the process resources are deallocated by operating system. So when all processes finish its execution, it is the responsibility of operating system to delete the particular process and to free the memory which it has occupied. Parent may terminate the execution of children processes using the abort system call. So whenever the parent process wants to delete its or terminate its child process, it can do using that abort system call. Some reasons for doing so, like child has exceeded allocated resources, or task assigned to child is no longer required, or the parent is exiting and the operating system does not allow a child to continue if its parent terminates. So in these cases, the parent can terminate its child process using the abort system call due to these reasons. Some operating systems do not allow child to exit if its parent has terminated. So when a parent process is created, and parent can also create its child processes, but when the parent process finishes its execution and wants to terminate, then even its child processes will be deleted, terminated. So without the parent process, the operating system does not allow the child to remain in the operating system. So if a process terminates, then all its children must also be terminated. What is cascading termination? All children, grandchildren, etc. are terminated. So when a parent process created, the children of that process can be created, and also children of that process can be created, that is grandchildren. So when the parent process is terminating, all its children, grandchildren has to be terminated. The termination is initiated by operating system. So this all termination will be done by the operating system. If no parent waiting, then terminated process is a zombie. If parent terminated without invoking wait system call, the process is an orphan. So let us understand what is this zombie process and orphan process. Zombie process. What is a zombie process? Zombie process is created when a parent process does not use the wait system call after a child dies to read its exit status. So the parent process before terminating has to be returned to the parent process, and parent process has to invoke wait system call. But when parent process does not use the wait system call after the child dies to read its status, then that parent process becomes a zombie process. A zombie process that has completed execution but still has an entry in the process table. But that parent process still has the entry because it has not invoked the wait system call. Orphan process. An orphan process is a process that is still executing but whose parent has died. Another definition, orphan is a child process that is reclaimed by init system call when the original parent process terminates before the child process. So the operating system does not allow the child process to remain in the system if its parent is not present in the system. So whenever the parent process terminates, even all children and grandchildren processes will be terminated. But if the parent dies before the child processes are terminated, then the processes who don't have the parent process but still remain in the system are called as orphan process. Next topic we'll see CPU scheduling. So this CPU scheduling is very important topic because based on this CPU scheduling, algorithms are based and which are very important from exam point of view also. And why we need this CPU scheduling? Because here will be decided for which process the CPU will be given for execution. So this decision has to be done in this CPU scheduling. So we have already seen this process states. In a new state where the process will be created and those will be brought to the ready state. In a ready state, the process will be waiting for their chance for execution, and using the short-term scheduler, the processes will be selected from the ready queue and will be given to the CPU for execution. So running state is nothing but the process is allocated to CPU for execution. So using the short-term scheduler, the processes will be selected and based on the various algorithms, the processes will be selected from the ready queue and will be allocated to the CPU for execution. So this decision has to be made in this CPU scheduling, which process has to be selected based on which conditions and all. So and algorithms will be very useful here to decide which process to be selected and to allocate the CPU for execution. Short-term scheduler selects from among the processes in ready queue and allocates the CPU to one of them. Queue may be ordered in various ways. So CPU scheduling decisions may take place when a process switches from running to waiting state as. Also whenever the process is, CPU scheduling decisions will be also taken whenever the process is also moves from running to waiting state and also switches from running to again ready state. So even here the CPU scheduling decisions are needed and also switches from waiting to ready state. So even in this case we need the CPU scheduling decisions, and next when it terminates which process to select. So in these all situations the CPU scheduling decisions are needed. Dispatcher module gives the control to the CPU to the process selected by the short-term scheduler. This involves, dispatcher is like a switching context. So whenever the CPU is given to any process, the what is its current status, that has to be saved and it is called as switching context. And switching to user mode, yes, from kernel mode to user mode, this will be taken care by the dispatcher, and jumping to the proper location in the user program to restart that program as. It will study the current status of that process from where to start the execution, earlier where it has till how much it has executed. This all will be read by the dispatcher. And dispatch latency is time it takes for the dispatcher to stop one process and start another process running. So if the previous process is running, to stop that process, and when to start another process execution or running, that time is called as dispatch latency. Basic concepts. So for the CPU scheduling, some basic concepts we need to understand, like maximum CPU utilization obtained with multiprogramming. So that care has to be taken that CPU must be utilized properly, CPU must be not kept idle. So the processes which are brought in the ready queue and the processes which are selected must be based on CPU and IO burst cycle. Okay, it is a combination. The processes which are brought is a combination of CPU and IO burst. So the process execution consists of a cycle of CPU execution and IO burst. That means CPU cycle means the processes which are using more CPU, and input output means the processes which are using more input output devices. So the processes which are using more input output devices will be moved to the waiting state where they will use the input output devices, and CPU burst distribution will be considered. So the processes has to be the combination of CPU and input output burst cycle, so that the CPU utilization must be utilized properly. It should be not idle. See alternate sequence of CPU and burst, that it is represented in a diagram. See load store. See CPU burst, the process which is using more CPU, then this is wait for input output burst, then again CPU burst, again input output. So like this way the process will be loaded and stored, and this is how the CPU burst and input output burst processes are used for execution. As we know that CPU scheduling algorithms are divided into two types, non-preemptive scheduling and preemptive scheduling. We already studied this in the previous topic. We also seen the differences between these. So all the scheduling algorithms are based on this non-preemptive and preemptive. So what is this non-preemptive scheduling? Non-preemptive scheduling is once the process is allocated to CPU, the process has to finish all its execution. Okay, the CPU will be not taken away from that process in between. The process has to finish all its execution, then only the CPU will be taken away from that process and will be given to another process. But whereas in preemptive scheduling, once the process is allocated to CPU, the CPU can be taken away from that process at any time in between the process. In between, the CPU can be taken away from that process, like if the high priority process comes or when the time expires of that process execution. So like this way the interruption comes in this preemptive scheduling based on the higher priority process or the time expires or any other matter. So based on this the algorithms are divided and the process will be selected from the ready queue by the short-term scheduler. Scheduling criteria. So some of the criteria which are considered for selection of the processes, like CPU utilization. So keep the CPU as busy as possible. That has to be taken care by the operating system. And throughput, the number of processes that complete their execution per time unit. So the process has to be executed fast and throughput has to be increased. So in a very less time, more processes has to be executed. So such processes has to be selected by the scheduling algorithms. Arrival time, the time when the process is arrived into ready queue. So even the time is very important here, when the process comes in the ready queue and for how much time it is waiting there. So this arrival time is also very important to select the processes. Burst time, the time required by process for its execution. So total time that process is going to take to complete its full execution. So this is also very important, how much time that process requires to complete the full execution. So based on this also the process is selected. Completion time, the time when the process completes its execution. So even the completion time is very important here. So based on this scheduling criteria, the scheduling algorithm considers these all criteria for process selection. Turnaround time, another amount of time to execute a particular process. Difference between completion time and arrival time. So turnaround time is nothing but amount of time to execute a particular process. It will find out the difference between arrival time and completion time, when that process has arrived and how much when it has got the CPU and when it has completed. So that difference will be calculated here. Waiting time, amount of time a process has been waiting in the ready queue. So waiting time of that particular process is also important. And then response time, amount of time it takes from when the request was submitted until the first response is produced, not output. That means when a process has arrived in the ready queue and when that process has got first response, that means when that process has given the first CPU for execution. Okay, and then in between the CPU can be taken away from that process, again the CPU can be given to that process. So when was the first response given to that process? That is a response time. Next, scheduling algorithm optimization criteria. So scheduling algorithm goals, you can say the goals of CPU scheduling. So the CPU scheduling goal is that to maximize CPU utilization. So it takes care that this algorithm takes care that how the maximum CPU utilization is taken, and there must be maximum throughput. In a less number of time, more number of processes has to be executed, and there must be minimum turnaround time. That means it calculates the difference between the arrival time and the completion time. So it should be the minimum time, and also the minimum waiting time. The process should be not allowed to wait for more time. So the process should be given less waiting time, minimum waiting time. The response has to be given fast to that processes which are waiting, and also minimum response time. So the first response to that process should be also minimum. So these are the goals of that CPU scheduling algorithms. So based on these goals it works. So the CPU scheduling algorithms are 4, which we are going to study 4 methods. First come first serve, shortage of first, priority based, and round robin. So in the next session we'll start with the first algorithm with the examples. First come first serve scheduling algorithm. Thank you.